You're listening to DTFHN for February 7th, 2026. I'm your mass-produced but artisanally finished host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who build things argue about how things should be built. Today's got that beautiful tension between who owns the tools and who owns the work. Let's get into it. I've spent enough time building distributed systems to know that the hardest part is never the code, it's the institutional will. You can write a beautiful protocol, design an elegant API, ship clean modules, pause, and none of it matters if the organization behind it doesn't commit to keeping the lights on. That's what makes our lay suite interesting. This isn't a weekend project. This is the French government, pause, specifically DNAM and ANCT, pause building and maintaining a full open source digital workspace. And they're doing it with Germany and the Netherlands. Think of it like a cathedral versus a bazaar, except in this case, the cathedral builders decided to publish every blueprint and hand out tools at the door. Le Suite is an umbrella project, pause messaging, video conferencing, document collaboration, file storage, project management, pause all MIT licensed, all open source. The architecture is modular. You don't adopt the whole thing or nothing. You pick the pieces that fit your infrastructure and wire them together. Now, the HN comments raise a fair point. Pause. This isn't Microsoft Office. It's not trying to be. The document editor is closer to a collaborative markdown tool than a full-featured word processor. And honestly, that's the right call. Most government document work doesn't need Excel macros or PowerPoint animations. It needs real-time collaboration, version control, and the ability to run the whole stack on infrastructure you actually control. Le Suite is solving for sovereignty, not feature parity. And sovereignty here isn't just a buzzword. When your national communications run through an American cloud provider, you've made a dependency decision that has geopolitical implications. Every API call crosses a jurisdiction. Every terms of service update is a policy change you didn't vote on. France looked at that and said, pause, we'll build our own, thank you. The engineering craft here deserves recognition. MIT license means anyone can fork it, extend it, deploy it. The cross-border collaboration with Germany's OpenDesk and the Netherlands. Mind Bureau means this isn't one country's pet project. Pause it, it's becoming shared European infrastructure. That's how open source wins at the institutional level, not by outspending the incumbents on features, but by making the switching cost zero and the trust model transparent. The funding critique in the comments is valid. Pause Europe talks a big game on digital sovereignty, but the budgets don't always match the ambition. But the code exists, it's running in production. French civil servants are using it today. That's not a white paper, that's a deployment. From sovereign software to sovereign eyesight, pause. Can Britain's over 70 drivers actually see the road? Let's pull this thread. Here's a question worth sitting with. When does a system designed to protect people become a system designed to exclude them? And how do you tell the difference before it's too late? The UK is rolling out mandatory eye tests for drivers over 70 every 3 years. On the surface, this is so obviously reasonable, it barely registers as news. Vision degrades. Driving requires vision. Test the vision done. But pull this thread a little and you find something more interesting than a policy announcement. The current system is essentially the honour system. You renew your license at 70 and self-declare that you can see well enough to drive. No actual test, no verification, just a form and your word now. Pause. I have enormous respect for self-assessment as a concept, but engineering taught me something about self-reported metrics. They're worthless without calibration. You don't ship software based on developers saying it probably works. You run the tests. The comment section surfaces the real tension here, and it's worth paying attention to. One camp says eye tests don't go far enough. Pause that what's really needed are full driving competency assessments. The other camp points out that older drivers already have free bus passes and public transit concessions, implying the infrastructure for graceful transitions exists. Both are right and both are incomplete. What catches my eye is the architectural question nobody's asking. Who controls this system right now? It's the DVLA, a government agency making binary decisions. Pause, you can drive or you can't. But the Waymo commenter from Austin raises something genuinely interesting. What if the answer isn't a gate that slams shut, but a gradient subsidized autonomous rides, shared mobility, a system that meets people where their capabilities actually are instead of drawing an arbitrary line? The Royal Society's framing is careful and correct. Pause support people to drive safely for as long as possible while ensuring timely action when needed. That's the right principle. But principles without implementation are just press releases. The Swiss commenter's mother stopped driving in her early 70s, and the transition was painless because the alternatives were already there. Online delivery, good transit, a culture that didn't treat losing your license as losing your identity. The eye test is the easy part. The hard part is building the system around it that actually works for people. And that part, pause, nobody's legislating. Next up, pause, a tiny piece of advice from 2009 that aged like fine wine. Start all your commands with a comma. There's a detail in this post that's easy to miss. The author runs a single command and gets back 21,733 results. That's how many executables are available in the Ubuntu repositories just in USAir bin alone. 21,000 names, all competing for the same flat namespace, and the solution he lands on is a single character. The comma, let me argue the other side for a moment, it shouldn't work. A comma is punctuation, it's visual noise, it violates every naming convention. Unix is built over 50 years. If you saw a file called comma mount in someone's home directory, you'd assume it was a typo or a temp file. You would not assume it was a carefully considered engineering decision. But that's exactly why it works. The comma is the one printable unshifted character on a standard keyboard that has no special meaning to the shell, no special meaning in file names, and no chance of colliding with any system command, past, present, or future. The author didn't just find an available character, pause, he found one that will remain available permanently because no package maintainer in the history of Unix will ever name a binary starting with a comma. It's a namespace reservation through sheer social improbability. The tab completion angle is what elevates this from clever trick to genuine workflow improvement type comma. Hit tab and you get exactly your commands. Nothing else. No scrolling through thousands of system binaries to find your 4 custom scripts. Is a perfect filter. Zero configuration required. Works in every shell on every system. No plugins, no frameworks, no dot file managers. One commenter mentions using double dashes in aliases, pause, git, dash, dash, progress, grep, dash, dash, rin. Same principle, different syntax. Another points out that Nix sidesteps the problem entirely by isolating packages into their own paths, both valid, but neither is as elegant as a single keystroke that partitions your entire command space. This post is from 2009, 17 years old, and the technique still works perfectly because it operates at a level below where software churn happens. It doesn't depend on any tool, any shell feature, any package manager. It's pure file feel pure convention, pure simplicity. Sometimes the most durable solutions are the ones that refuse to be sophisticated. A comma, that's it. No dependencies, no installation, no maintenance, no possibility of breakage. The kind of solution that makes you wonder why you ever reached for anything more complicated. Next up, Hoot is a scheme to WebAssembly compiler, and if you care about language diversity on the web, this one's worth your attention. In 1998, the Java virtual machine was supposed to be the universal runtime write once, run anywhere. Sun Microsystems bet the company on it, and it worked, pause sort of, but the JVM was Sun's, the spec was open, the politics were not. And when Oracle acquired Sun in 2010, every developer building on that foundation learned what it means when someone else holds the keys to your platform. WebAssembly is the second attempt at that same dream, a universal bytecode, but this time born from a W3C standard implemented independently by every major browser engine. No single company controls it, no acquisition can change the terms. That architectural difference matters more than any technical benchmark. Which brings us to Hoot from the Sprightly Institute. Hoot compiles scheme, pause one of the oldest and most elegant languages in computing, pause to WebAssembly with garbage collection support, a language designed in 1975, running on a runtime designed in 2015. And the remarkable part is how natural the fit turns out to be. The technical substance here is worth pulling apart. Hoot is built entirely on Guile, the GNU scheme implementation, no external dependencies. The toolchain is self-contained to the point where you can compile scheme to WASM, then test the resulting binary inside your Guile REPL without ever touching a browser. That's a development loop that most modern JavaScript frameworks can't match. Pause and scheme has been around for 50 years. One commenter nails the historical irony perfectly. JavaScript was supposed to be scheme for the browser. Brendan Ike originally wanted to put scheme in Netscape Navigator, but management forced the C/Java syntax on the language. 30 years later, Hoot quietly delivers on that original promise through the back door of WebAssembly. The language that was supposed to be there from the beginning finally arrives, carried by a runtime that doesn't care what syntax your source code uses. Sprightly is building this as part of their larger work on decentralized networks and object capability security. Hoot isn't a toy or a demo. It's infrastructure for a vision of computing where programs can move between machines, run in sandboxed environments, and compose safely. Pause all properties that Scheme's minimalist design makes tractable in ways that larger languages struggle with. The tools exist, the compiler works, the runtime is an open standard. Sometimes the future looks exactly like the past, just finally given the platform it deserved. That's 4 down, 6 to go. Next up, Pause first proof, where mathematicians encrypt their answers and AI tries to solve the problems. The comments on this one are worth starting with because they reveal something the title alone doesn't. A few mathematicians looked at the problems posted on First Proof and immediately recognized what they were dealing with. These aren't puzzle book exercises. These aren't competition problems designed to have elegant solutions. These are research level questions. Pause, the kind of thing you'd encounter deep in a PhD, the kind of lemma that sits on a whiteboard for weeks before someone finds the right angle. The setup is straightforward. The organizers post mathematical problems whose answers they already know but keep encrypted. AI systems attempt to solve them. If a system produces a correct proof before the deadline, that's evidence of genuine mathematical reasoning, not pattern matching against training data, not regurgitating known results with slightly different notation. One commenter cuts right to it. Humans can solve these too. So what's the benchmark actually measuring? And that's the interesting design challenge. The encryption window is short. February 13th is the deadline. The problems are fresh enough that they haven't leaked into any training corpus. What you're testing isn't whether an AI can look up the answer, pause, it's whether it can do the work. Pull this thread a little further and you hit the bootstrapism question. The project is hosted openly. The problems are public. Anyone, human or machine, can attempt them. That's the right architecture for this kind of benchmark. Compare it to the alternative, a closed evaluation where a company runs its model against secret problems and publishes only the results it likes. You'd learn nothing except what they wanted you to believe. The comedic edge here is subtle but real. We've spent years watching AI benchmarks get gamed, saturated, and rendered meaningless within months of publication. MMLU, Human Eval, all of them pause, designed to measure something, then immediately optimized against until the number goes up, but the capability doesn't. First Proof tries to sidestep that entire failure mode by making the problems genuinely novel and time limited. Whether it works depends on whether the organizers can keep generating problems faster than models can be fine-tuned against them. The tools are open, the challenge is public. The question isn't whether AI can do math pause, it's whether we can build an honest test of that claim. That distinction matters more than the results. From encrypted proofs to preserved classics. Pause. OpenCiv 3 is rebuilding Civilization 3 from the ground up. Let's see how. What's the fundamental constraint when you love a 23-year-old game? The engine rots, the platform support narrows, the mod tools hit walls that were baked in at compile time, and the company that built it has moved on to sequels with entirely different design philosophies. Your favorite game becomes a museum piece running on compatibility. Shim's OpenCiv 3 attacks that constraint directly built in Godot with C cross-platform from the ground up. And Pause, this is the part worth paying attention to. Pause designed around modding as a first-class architectural concern. They're not just re-implementing Civ 3, they're removing the arbitrary limits that modders spent 2 decades working around. Hard-coded unit caps, broken diplomacy mechanics, graphics pipeline restrictions, all of it open for modification. The technical approach is genuinely clever. You can point it at your existing Civ 3 installation and it imports the original assets, pause, maps, units, terrain, all of it. Or you run it standalone with placeholder graphics. That separation between engine and content is exactly the kind of architectural decision that makes a project like this sustainable. The game logic doesn't depend on proprietary art. The proprietary art is an optional enhancement. Pause, one of the commenters, nails why this matters. Civ 3 is still their go-to for long flights. Pause, quote, the best way to instantly time travel forward 12 hours. That's not nostalgia talking. That's a game whose core loop is so well designed that decades of graphical improvement in its sequels haven't replaced it. The question everyone avoids asking about game preservation is this: why do we accept that software has an expiration date? We don't accept it for books, we don't accept it for music, but games, pause, interactive systems that represent genuine cultural achievement, pause, we let them die when the platform moves on and the publisher stops caring. OpenCiv 3 is a direct challenge to that assumption. The game can outlive the company, the community can outlive the product cycle. It's early pre-alpha rough edges, missing late game mechanics, but the foundation is right. Godot is open, the code is open, the mod architecture is open. Someone on Civ Fanatics is doing the same thing for Civ. These projects aren't competing with modern civilization games. They're preserving the ones that earn their place, pause, and making them better in the process. That's how it's supposed to work. We talked earlier about training models to be useful. Pause. Well, here's the mechanism. Next up, reinforcement learning from human feedback. Imagine you're training a system that's smarter than you at chess and your job is to tell it which moves are good. You can't outplay it. You can't even fully evaluate its positions, but you can look at 2 moves side by side and say, this one feels right. That intuition scaled across thousands of people making thousands of comparisons is the engine underneath almost every large language model you've used in the last 3 years. RLHF, reinforcement learning from human feedback, and now there's a full book on it, open access, available at rlhbook.com. Let's pull this thread because the engineering here deserves real appreciation. The core insight is deceptively simple. You can't write a reward function for be helpful and don't be weird. Human preferences are too messy. too contextual, too shaped by culture and expectation. But you can collect pairwise comparisons, pause response A versus response B, which one's better, pause, and train a reward model that learns to approximate human judgment. Then you optimize the language model against that learned reward signal using proximal policy optimization or one of its descendants. 3 stages: supervised, fine-tuning, reward modeling, policy optimization. Each one has its own failure modes, its own research frontier, and its own set of engineering decisions that compound downstream. Run this forward 5 years. The bottleneck isn't compute, it's the quality and diversity of human feedback. Who are the annotators? What biases do they carry? What happens when the reward model learns to exploit patterns in human judgment rather than genuinely satisfy human intent? Pause the so-called reward hacking problem. These aren't hypothetical concerns, they're active research questions with real consequences for every system built on this foundation. What makes this book matter is that it's open, not behind a paywall, not locked to a university course, not gated by institutional access. The web version has working links, references, the full treatment. Anyone with a browser and the will to learn can understand the machinery that shapes how these models behave. That's not a small thing. The technique that determines whether your AI assistant is helpful or hostile, cautious or creative, pause the blueprints for that, are sitting on a public website. Free. This is the kind of resource that changes who gets to participate in the conversation. The tools exist, the knowledge is available. Now go build something with it. Now, from learning how the machines think to the humans who've been building them all along, pause 25 years of lessons from the trenches. Let me still man the case against this kind of post 25 years of anecdotes from one developer. No frameworks, no architectural insights, no lessons learned section with numbered takeaways in a world drowning in content. Why should anyone care about one person's stories about jumping to reset vectors and viewing HTML source in Internet Explorer? Here's why that argument collapses on its own terms. Strip away the marketing language around thought leadership and actionable insights and ask what actually makes someone a better engineer. It's not the listicles, it's not the 10 things I learned at Google Posts. It's the moment someone looks over your shoulder in a university computer lab, opens ViewSource and writes a font tag in Notepad. That 10-minute tutorial in 2001 set Susan Powell on a lifelong path of building personal websites. No course, no bootcamp, no subscription, just one person showing another person how the thing works. The reset vector story is even better. A student wonders aloud whether jumping to FFFF:000 on an 88.6 will reboot the machine, opens dbid.exe, tries it. The machine reboots instantly, and a classmate who'd been grinding for top marks watches this happen and has a genuine shift in perspective, pause away from academic competition, and toward the joy of actually exploring how computers work at the bare metal level. That's not a lesson you can package into a Medium post with a stock photo header. What Susan gets right, and what the comments pick up on, is that these stories are about people, not systems. A telecom carrier rep telling the set-top box vendor to shut up the accidental discoveries, the human friction and surprise that no tutorial can simulate. The first principles here are simple software development is a craft learned through contact with other humans who are curious. The web was built on ViewSource. The knowledge was never gated. Pause. Anyone could right-click and see how it worked. That architectural decision, making the source visible by default, created more developers than any bootcamp pipeline ever will. 25 years of stories, no wisdom offered, none needed. The stories are the wisdom. From viewing source code to viewing the road ahead. Pause. Waymo is teaching cars to understand the world. Let's pull this thread. I spent years building simulation environments for distributed systems, and the hardest problem was never the happy path. It was generating the scenarios you haven't seen yet. You can replay every log you've ever collected, but the crash that matters is the one that hasn't happened. That's the fundamental constraint. Waymo is attacking here, and their approach is genuinely clever. They're taking Genie 3 DeepMind's general-purpose world model, trained on an enormous corpus of video, and post-training it to output not just camera imagery, but three-dimensional LiDAR data that matches Waymo's actual sensor suite. That second part is the breakthrough. Other companies have video world models. Nobody else is synthesizing geometrically accurate LiDAR point clouds from two-dimensional video input. That's the difference between a pretty visualization and something you can actually feed to a self-driving stack for meaningful testing. Follow the logic all the way. If your world model only knows what your fleet has driven through, your simulation ceiling is your experience ceiling. You can't test tornado response if you've never driven through a tornado. You can't test elephant avoidance if your fleet operates in Phoenix and San Francisco. But if your world model inherits broad physical intuition from millions of hours of general video, then you can prompt it with tornado on the Golden Gate Bridge and get a physically plausible multi-sensor simulation. The test distribution becomes wider than the training distribution. That's a genuine capability unlock. One of the comments nails the bigger picture. This is why DeepMind's world model research suddenly makes strategic sense. Waymo isn't just a self-driving car company, it's a robotics company, and world models are the simulation backbone for any embodied AI system. The same architecture that generates driving scenarios today generates warehouse, logistics scenarios, or surgical environments tomorrow. Now, the open question, Waymo is Alphabet. This is proprietary infrastructure built on proprietary models, trained on proprietary data. The research is published. The system is not if world models become the foundation for testing safety critical AI, and one company controls the most advanced one. That's a concentration of capability worth watching. The 200 million autonomous miles are real. The safety record is real, but trust us, we simulated it. Only works when the simulation itself can be examined. The technology is remarkable. The question is whether anyone else gets to build on it. From simulating the physical world to navigating the digital. Pause, let's talk about coding agents. Can a tool become so good at building things that it makes your other tools obsolete? It's the kind of question that sounds abstract until you watch it happen in real time. There's a pattern in manufacturing called tooling up. Before you build the product, you build the jigs, the fixtures, the custom machinery that makes production possible. The tooling phase is expensive, it's slow, and historically, once you've tooled up, you're locked in. Retooling costs almost as much as starting over. Frameworks are software's version of tooling. You pick React, you pick Rails, you pick whatever the current orthodoxy demands, and now your product is shaped by that choice forever. Every architectural decision downstream is constrained by that initial commitment. What this author is describing, pause, and the HN comments are genuinely split on whether to celebrate or panic, pause, is what happens when the cost of tooling drops to near zero, when a coding agent can generate bespoke infrastructure as fast as you can describe what you need. The rationale for adopting someone else's framework weakens. You're not choosing between build it yourself in 6 months and use this framework in 2 weeks. You're choosing between describe exactly what you need and get it in an afternoon and adopt a general purpose solution that solves problems you don't have while creating problems you didn't expect. The comments push back hard and they're not wrong. Frameworks carry institutional knowledge, security patches, battle-tested edge case handling. One commenter draws the Tolkien analogy, pause, imagine giving an author a machine that writes prose instantly. You still need someone who understands narrative structure, character, theme. The machine handles output, the craft remains. That's precisely the author's point, though. 20 years of laying bricks means you know exactly which bricks go where. The agent handles the laying. The architecture is still yours. Where this gets genuinely interesting is the implied open source angle. Every framework is someone else's opinion crystallized into a dependency. Coding agents, particularly open ones running local models, let you crystallize your own opinions into code without adopting anyone else's structure. That's not the death of frameworks, it's the birth of frameworks of one, generated on demand, shaped to the problem, disposable when the problem changes. The forge is automated. The blacksmith still decides what to make. This has been your daily tech feed for Hacker News for February 7th, 2026. This podcast is entirely I generated scripts by Claude Opus 4.6, voiced by Quen3TTS, not affiliated with Hacker News or Y Combinator. Now go build something that outlasts the tools you built it with. We'll see you back here tomorrow.